Hello everybody. In step 6 of Glaciers and Glacial Geomorphology, we're talking about glacier structure or anatomy. And in this first unit, I'm going to be talking about the supraglacial and the end-glacial zones. In other words, the very top surface of the glacier and the interior of the glacier. As always, there's some very basic reading for you to begin with, and then there'll be more advanced reading for you to move on to, details on the KLE. The basic reading is chapter 5 of that old 1999 textbook that just gives you a starting point at the right level to get into the literature on this topic, but it's really important that you follow up with more recent literature, both items that I'll recommend on the KLE and items that you find for yourselves by searching into recent and current literature in glaciology. So what are the key points that we're going to be making? Well, the first key point is that the characteristics of a glacier vary with depth through the glacier. The surface is different from the interior, which is different from the bed, but there are a lot of different characteristics that vary. I'll talk about some of them in detail. The others you can read up on in the basic text. For example, the density of the ice, the temperature, the debris content, the crystal size, the chemical composition, the isotopic composition, the stress profile. You already have experience of calculating stress variations, strain variations, and velocity variations through the thickness of a glacier. So lots of characteristics of a glacier vary with depth from the surface through to the bed. Therefore, because of that, the behavior of the ice and the behavior of the glacier can be predicted to vary with depth, especially once you look at the characteristics of the basal ice layer compared with the end glacial layer. You would predict that the basal ice will behave differently from the ice above it because it has different debris characteristics, etc. So if we're going to understand how glaciers behave, particularly how they behave through their depth, well, that understanding of dynamics, hydrology, the geomorphic impact, that's going to depend partly on an understanding of this structure or anatomy of the glacier. Now, I'll talk about the basal ice layer in more detail next time, in the next unit, but in this unit, I'm going to focus on glacier surface morphology in particular, and we're going to see how the surface morphology, the shape of the surface of the glacier, the features that you see if you look at a glacier, if you stand on a glacier and walk around, that surface form, that surface morphology is controlled by lots of different factors, including whether you're in the accumulation zone or the ablation zone. It depends on strain or dynamic effects such as crevassing. It depends on melting and fluvial, glacier fluvial processes, and differential ablation controlled, for example, by variations in debris cover around the surface. So we can look at that as a little case study of how different details, different things about the surface of the glacier have an impact on glacier surface morphology. Now, this classic diagram from Lawson's 1979 paper about the Matanuska Glacier illustrates some of the terms that we've already introduced in a previous session. So in this cross-section through the Matanuska, notice the scale varies at different points in the cross-section. He talks first of all about what we would call the supraglacial zone, or in American terminology, the superglacial zone, which is just the upper few centimeters, or well, here he has it to 20 centimeters, the upper surface of the glacier, beneath which we have here 300 meters of the end glacial zone, the interior bit of the glacier, before we reach at the bottom of the diagram here just maybe up to 20 meters or so of what he calls the basal zone. Now, within each of these zones, he's divided it up, and we commonly talk about different facies of ice. So within the end glacial zone, for example, he differentiates between the diffused facies, which occupies most of the end glacial zone, and just occasionally these bands, or the banded facies. And you can see what the difference between those is if you look on the right-hand side here, where you see a graph. Notice it's a logarithmic scale, the debris volume in these different layers. And in the diffused facies of the end glacial zone, the debris content is down here at the level of, well, 0.001%, so extremely low debris content. We're talking here about the occasional speck of dust. But then in these occasional layers, banded facies, we get much higher debris concentrations of maybe 1, 2 or 3%. So we have layers where there's a greater amount of dust. This information about debris content also gives you a clue about what's different about the basal zone. The stratified facies here can have 20, 30, 40, 50% by volume debris content. Even the dispersed facies, which is lower, can still have several percentage debris content, similar to the banded facies in the end glacial zone. So we can identify different sections of the glacier, and we'll talk about some of the nomenclature, particularly about the basal zone, in the next unit. And we can begin to identify some of the characteristics that vary with depth through the glacier between these different zones. Just to give you one more example based on Lawson's work, here's his diagram showing where we are in the glacier, and here's a diagram showing the delta oxygen 18 value, the stable isotope value, working our way down through the glacier. And without going into any detail about why the stable isotope values vary with depth, at this stage I just want to point out that they do. And as we progress steadily through the end glacial zone and into the dispersed facies of the basal zone, we're down at levels around about -24 parts per mil, delta oxygen 18. But then there's this sudden step upwards of 3 or 4 parts per mil from -24 up towards -20 parts per mil as we go down into the stratified facies. So something different is going on here. We have a different stable isotope chemistry in the stratified facies from what we have in the dispersed facies and the diffused facies. And this also gives us our first little bit of an idea about the complications in dividing the glacier up in these ways, is that having said there's a basal zone and an end glacial zone and started to put a barrier or a boundary in there between them, we now see that when we look at the isotopes, that boundary doesn't appear to coincide in isotopic terms with where we've put it in terms of the debris content, for example. So there's something we need to look at in more detail later on about the stable isotope composition of the basal ice layer, and we'll talk about that in a lot more detail next time. Just one more example before we move on to something a little bit different of variations with depth through the glacier. I thought I'd just throw in this diagram of the temperature profile through the middle of the Greenland ice sheet from the surface all the way down towards the bed. And you can see for a variety of different reasons there, the temperature of the ice varies with depth, partly, for example, because of warming from the bottom, heat coming up from underneath the glacier, and partly because we're burying ice of different temperatures that reflect different surface temperatures at different points in history. Again, this is something we're going to come back to and talk about in specific detail in a future section, but I just wanted to mention it now as another example of how things vary with depth through a glacier. So if you remember back now to when we were drawing our profiles of stress, strain and velocity through a glacier based on the idea of the shear stress equation and Glen's flow law, remember that we did say that Glen's flow law had this temperature dependent hardness parameter in it, but then we just kind of ignored it. Well, think back to that now and think about these varying temperatures with depth, and especially the fact that the ice warms significantly as we approach the bed. What impact is that going to have on the stress-strain relationship? What impact is that going to have on our calculation of the strain rate at different depths through the glacier? Certainly it is going to have an impact, and that's something now that you can build into your growing understanding of how these various complicating factors tie together. On that note, I'm going to pause just here and give you a chance to think about the things that we've talked about in terms of the end glacial facies and the general idea of change through depth within the glacier. And then I'm going to come back in the next video and I'm going to talk about the glacier surface specifically and how the morphology of the glacier surface is controlled by a variety of different factors.